Hello and welcome to Mr. Tompkins EdTech and my series of walkthroughs for the AQA GCSE Mathematics past papers. This particular video is November 2017, Paper 1, Higher Tier. Now, with the new specification being new, Grade 9 to 1 past papers are like gold dust and you should not be watching this video unless you've already attempted the paper yourself under test-like conditions. If you haven't, stop the video now and go and do it first. I'm serious, go. Still watching? That's great. Why not subscribe to my channel so you can easily find it again the next time you want some help with your maths. I have plenty of A-level content too, so make sure you come back and check that out if you're carrying on with your maths next year. Please hit the like button if you found the walkthrough helpful. This really helps out my channel and it makes it much easier for others to wade through all the YouTube dross and find the good stuff. Also, before attempting the actual past papers, make sure you've gone through all the practice sets first. AQA produced 4 sets of practice papers to help students prepare for the new GCSE exams, and I would advise you to work through these before moving on to the actual past papers. Have a look at this video series which gives full walkthroughs for AQA practice sets 1 to 4. If you don't happen to have a copy yourself, you'll find a download link to the practice paper in the description below each video. Finally, feel free to ask questions below. It would be helpful if you include a question number and be as specific as possible. I really appreciate your comments and feedback and I try to respond to these as quickly as I can, especially around exam times. Okay, let's get into it. Question 1. Work out the root of 2 to the power 6 plus 6 to the power of 2. Okay, so we've got 3 different types of operations going on here. We've got a square root, we've got a plus, and we've got some squares. So we need to work out which order to do these in to get the question right. Let's have a look at BIDMAS. BIDMAS says brackets first, then indices, then division, and then multiplication, and then addition and subtraction. So normally we would do the indices first. Now the indices here is going to be the squares and the square root. But just take care because this square root goes all the way across the numbers. There's actually an implied pair of brackets in here. It's actually that what's going on. We're taking the square root of 2 to the 6 plus 6 to the power of 2. So actually we need to do what's in the brackets first. So inside the brackets we've got squares and plus, so indices come before addition. So we're going to do the squares first. 2 to the power 6, 2 times itself 6 times is 2, 4, 8, 16, 32, 64. So I'm going to get 64 plus 6 squared. 6 squared is 36. And that needs to be square rooted. 64 plus 36 is 100. And the square root of 100 is going to be 10. So it's that one there. Question 2. What is 800 million in standard form? Now, 800 million. A million is a number followed by 6 zeros. So 800 million is going to be 800 followed by 6 zeros. Just going to look like that. So if it's in standard form, we are going to have it as a number between 1 and 10 times by 10 to the power of something. Now if we count the number of jumps that we'd have to do there, that's 1, 2, 3, 4, 5, 6, 7, 8 jumps to the left. I can rewrite that as 8 times 10 to the 8. 1, 2, 3, 4, 5, 6, 7, 8. That's right, isn't it? So it's going to be that one there. Question 3. Circle the expression that is equivalent to 4a to the power 5 all squared. Now when you have an index of an index here, this index actually gets distributed to everything inside. So I'm actually going to be squaring 4 and I'm going to be squaring a to the power of 5. 4 squared is 16 and a to the 5 squared, a to the 5 times a to the 5 is a to the 5 times 2 is a to the power of 10. Multiply those two indices together. So the answer is 16a to the power of 10. It's that one there. Question 4. Y equals 10 divided by x. If the value of x doubles, what happens to the value of y? Okay. Now let's imagine that x was equal to 1. Then y would be 10 divided by 1, so y would be 10. Now if I then choose to double x, then x would now be 2 lots of 1, which is 2. And y would be 10 divided by 2. 10 divided by 2 is 5. So you can see from here to here, my value of x has doubled. And from here to here, my value of y in the same time has halved. So it's going to be that one there, divided by 2. Question 5. Factorize x squared minus 100. Now, you should spot immediately that this is the difference of two squares. It's a very well-known type of quadratic, crops up a lot. So I already know what this is going to look like. It's going to be two brackets like this, and x squared, the square root of x squared is x, so I'm going to have an x here and here. The square root of 100 is 10, so I'm going to have a 10 here, here and here. And then I'm going to have a plus in that one and a minus in that one. This is called the difference of two squares, and it always comes out like this. Okay, you just need to remember this identity really. A squared minus b squared is equal to a plus b. A minus b comes up a lot, so it's an identity, so it's got 3 equal signs in there. Yeah, so remember that and you can't go wrong with these. 5b, solve 7x plus 6 is greater than 1 plus 2x. Now this is a linear inequality with unknowns on both sides. You can work these out pretty much the same way as you'd solve an equation, collecting the x's on one side and the numbers on the other. As long as you don't divide through anything negative, that should work fine. So I'm going to take this plus 2 and move it over here, and I'm going to take this plus 6 and I'm going to move it over here. So it works the same way as equations. If you change sides, you change signs. So my 7x, if I take the 2x over, it will become minus 2x, and that's going to be greater than 1, which was already there, and I'm moving the plus 6 over, it's going to become minus 6. So 7x minus 2x is greater than 1 minus 6. 7x minus 2x is 5x. That is greater than 1 minus 6 is minus 5. And then dividing both sides by 5, I'm going to get x is greater than negative 1. Okay. Just take care with inequalities. You avoid trying to divide through by negative numbers, and you should be fine. Okay, so x is greater than minus 1 is the solution. Question 6. Work out the value of the square root of 3 squared times the square root of 2 squared. Okay. Now you'll realize that square rooting and squaring are opposite operations. So square rooting something and then squaring it again will give you back what you started. So the square root of 3 then squared is going to just be 3, and the square root of 2 squared is going to be 2. So the answer is 3 times 2, which is 6. So very easy. Question 7. Here is a quarter circle of radius 6 centimeters. Work out the area of the quarter circle and give your answers in terms of pi. Okay, so you probably remember the formula for circumference and area of a circle. If you're struggling with it, cherry, pie, delicious, apple, pies are 2. Handy way of remembering it. So here we want area, don't we? So it's this formula that we're after. We don't have a whole circle, got a quarter of one. So then the area of this quarter circle is going to be a quarter of pi r squared, where r is the radius, r is 6, so that goes in there. So my area is going to be 1/4 of pi times 6 squared. 6 squared is 36. So that is equal to 1/4 of pi times 36, and 1/4 of 36 is 9. So the answer is 9 pi. Question 8. Three whole numbers are each rounded to the nearest 10. The sum of the rounded numbers is 70. Work out the maximum possible sum of the original three numbers. And that's quite a confusing question, really. I think sometimes if it's not clear how to proceed, then perhaps let's just try and do some numerical answers and see if we can work out what patterns there are or what the underlining things are. So let's have a look. So three whole numbers are each rounded to the nearest 10 and they sum to 70. So let's say that my three numbers rounded are 40, 20 and 10. That would add up to 70, wouldn't it? Okay, so what is the maximum number then that would round to 40? Now remember, these are whole numbers, so they can't be like point anything. So the biggest number that rounds to 40 is going to be 44, isn't it? Because 45 would round up to 50. Similarly, 24, the largest number that rounds to 20 is going to be 24, and the largest number that rounds to 10 is going to be 14. So if you add those up, you're going to get what? 4, 8, 12 more than 70. It's going to be 82. Okay, so that's one possibility. So let's just have another look at a different one. So perhaps instead of having numbers that rounded to 40, 20 and 10, we had a number that rounded to 30 and then two numbers that rounded to 20. Does that change anything? So that adds up to 70 again. So the largest number that rounds to 30 is going to be 34. The largest number that rounds to 20 is going to be 24, and the largest number that rounds to 20 is going to be 24. So again, that's like 4, 8, 12 more than 70, isn't it? So I think whatever combination of numbers that you pick that round to your original 70, your maximum possible number is always going to be 4 more than that 3 times. So 4 times 3, 12 more than that amount. So the maximum possible sum has to be 82. Make sense? Question 9. Circle the expression for the range of n consecutive numbers. Okay, so first off, what does range mean? Range means highest minus lowest, doesn't it? So range equals highest value minus the lowest value. Okay, now let's consider our n consecutive numbers. Now we don't know what the first number is, so let's call it a. Now my next number is going to be one more than that because these numbers are consecutive, so I'm going to have a plus 1. Then I'm going to have a plus 2, and then so on. Now what's my last number going to be? Now it's not going to be a plus n, because that means I would have n plus 1 numbers, so it's got to be a plus n minus 1, giving me n numbers altogether. Okay, so then if I take my highest number, a plus n minus 1, and take away my lowest number, a, then my range is going to be a plus n minus 1 take away a, which is n minus 1. So it's that one there. Question 10. 3 identical isosceles triangles are joined to make this trapezium. Each triangle has a base of b and a perpendicular height of h. Work out an expression in terms of b and h for the area of the trapezium and give your answer in its simplest form. Okay, so first off, we know that these are 3 similar triangles. So if the baseline of that middle triangle is b, then this also has to be b, and this also has to be b. So that's quite helpful, because then if this is from b to here, we know that this must be 2b from here to here. Now the formula for the area of a trapezium is given by half a plus b h, where a and b are the 2 parallel sides and h is the perpendicular distance between them. Now in this particular case, my a is going to be b and my b is going to be 2b. So I'm going to have b plus 2b. That's my 2 parallel sides, and my h is still h there. Okay, so just to make that very clear, my a is going to be this one up here, which in this case is b. My B of my formula is going to be this one here. It's my second parallel line, and my H is just a H. Okay, so there's that one there. So just subbing those things in, I've got half B plus 2B times H. Okay, so B plus 2B is 3B, so that's half of 3B times H. And I can just rewrite that as 3 over 2 BH. There's a kind of simpler way of writing that down. 10b, this diagram shows the same trapezium, and now we're told that this side here is S, and that the ratio of B to S is 2 to 3. And now we need to work out the perimeter of the shape in terms of just B. So we need to express S in terms of B, basically. So if B to S is 2 to 3, then S is going to be, well, you're going to take B and you're going to divide it by 2 and times it by 3, so it's going to be 3B over 2. Okay, so S is 3B over 2. So if that's 3B over 2, that's B. So for along here was 2B, wasn't it, from before? And then up here is going to be 3B over 2 again. So adding those four sides together is going to give me the perimeter. So my perimeter is going to be my top line B, B plus my S, which we, plus my S, which we worked out to be 3B over 2, plus the baseline, which is 2B, plus the other slanty line, which is another 3B over 2. Okay, now 3B over 2 plus 3B over 2, so they're two halves of the same thing, aren't they? So that's going to give me 3B. So 3B plus 2B plus B is going to give me 6B altogether. So P is equal to 6B. 6B centimeters. Question 11. 4 candidates in an election are A, B, C, and D. The pie chart shows the proportion of votes for each candidate. Now you can see in the pie chart that most of those have been given algebraically. This one here is a right angle, so we must know it's 90. And the other three are algebraic. So I think the first thing we need to do really here is work out what x is. So we know that those three angles there must add up to 360. So let's form a linear equation in x that we can solve. So our four angles, which are 90 plus our x plus the 2x plus 10 plus the 2x, that's got to add up to 360 degrees because there's 360 degrees in the circle. So collecting like terms, I've got an x, a 2x, and a 2x, which adds up to 5x. And I've got a 90 and a 10, which adds up to 100. So 5x plus 100 is 360. Okay, then change sides on that 100. Move it over to the other side. I'm going to get 5x equals 360 take away 100, which is 5x is equal to 260. And then finally I can cross multiply by that 5. So x equals 260 divided by 5, which is, well, dividing by 5 is like dividing by 10 and doubling. So 260 divided by 10 is 26, times 2 is 52. So x is 52 degrees. Okay, so now I know that, I can now answer the question, work out the probability that a person who voted, chosen at random, voted for C. So probability, you will remember, is equal to successful outcomes divided by total outcomes. And in this case, successful outcomes is for C, isn't it? 2x plus 10. So 2x plus 10 over total outcomes is everybody. That's 360 degrees. Remember, these are in degrees at the moment. So I know now that x is 52. So that is going to be equal to 52 times 2 is 104 plus 10 is 114 divided by 360. Now that probably cancels down, but this is a non-calculated paper, so I can't chuck it in there, and it's a probability question and they never give you marks for cancelling these down. So you might as well just leave it like that, 114 over 360. Question 12. Use approximations to one significant figure to estimate the value of 0.526 times 39.6 squared divided by the root of 97.65. Okay, so I'm going to have to take each one of those numbers, round it to one significant figure first, and then do the maths. So let's take the first one then, 0.526. I need to round off after the 5. That's the first significant figure. So I'm going to be rounding that one down. And that's going to give me 0.5. 39.62. I'm going to be rounding off after the 3. So that rounds up this time. It's going to be rounding up to 40. So 0.5 times 40 squared divided by 97.65. I'm going to round off after the 9. So I'm going to round up. So 9 goes to 10. So it's actually going to be at 100, isn't it? So root 100. So I'm going to 0.5 times 40 squared, all divided by the root of 100. Okay, bid maths. Got to do the powers first. Brackets, indices, division, multiplication, addition, subtraction. So the indices come first. So 0.5 times 40 squared. 40 squared is 40 times 40. 40 times 40 is 1600. So I'm going to get 0.5 times 1600 divided by, well, the square root of 100 is just 10, isn't it? Okay. So now what can I do? I can cancel that 10 in with one of those. So I'm left with 0.5 times 160, and timesing something through by the half is the same as halving it or dividing it by 2. 160 divided by 2 is 80. So my answer is 80. Question 13. We're given that the ratio of x to y is 7 to 4 and that x plus y is at 88, and we need to work out the value of x minus y. Okay. So now this is well, if I rewrite this, x to y, or the ratio of x to y is 7 to 4. If I write that as an equation, I can say that y then is equal to, well, take x, I can get y if I divide it by 7 and times it by 4. So 4/7 of x, y is 4/7 of x. Now you've got two different methods for solving simultaneous equations, either by elimination or by substitution. This one lends itself more to solving by substitution, so that's the method that I'm going to pick. So I'm going to call this one here equation 1 and this one equation 2. And I am going to substitute. Oops, no, I'm not going to write in that weird pen. I'm going to substitute equation 1 into equation 2. So that gives me x plus y. Now I know from the other equation that y is equal to 4 lots of x over 7. So x plus 4 lots of x over 7 is equal to 88. Okay, so how many x's have I got? If I've got x plus 4/7 of x, x is 7/7 of x. So 7/7 of x plus 4/7 of x is 11/7 of x. So 11x over 7 is equal to 88. So dividing through by 11 and timesing through by 7 should give me x. So then x is equal to 88 divided by 11 is 8 and times by 7 is 56. So x is 56. Okay, so I know that x is 56 and I know that x plus y is 88. So y must be equal to 88 take away 56, which is 32. Okay, so now I know x and y, I can now work out what the value of x minus y is. So therefore, x minus y then is going to be my value of x, 56, take away my value of y, which is 32, and that gives me 24. Question 14. Two congruent regular polygons are joined together. And we've got a picture of them here, and then we need to work out the number of sides of each polygon. Okay. Now, if the angle between those two polygons is 60, now if I draw another line in here, just extend that line up a bit like that, then that angle there is going to be 30, and that angle there is going to be 30. Now this is the exterior angle, isn't it? The one I've just found in here. This is going to be the exterior angle. And I know it's 30 degrees. Now, the number of sides, well, the exterior angle of a polygon is given by 360 divided by n, the number of sides. Now, I know here what the exterior angle is. What I don't know is n. So just taking those two and switching them around, I should say that n, the number of sides, is going to be 360 divided by the exterior angle. In other words, it is 360 divided by 30. So 30 is into 360. Go how many times? 12 times, I think. So then this has got to be a 12-sided polygon. 12. Question 15. A meal deal is choose one sandwich, one drink and one snack, and there are 7 different sandwiches, 5 different drinks and 3 different snacks. How many different meal deal combinations are there? Well, you can work out the total number of combinations by taking the number of sandwiches and multiplying it by the number of choices of drinks and multiplying that by the number of choices of snacks. So 5 times 3 times 7. 7 5s are, what's that, 35 times 3, 105. So it's going to be 105 different combinations. 15b says 2 of the sandwiches have cheese in them and 3 of the drinks are fizzy. Either picks a meal deal at random, work out the probability that the sandwiches have cheese in it and the drink is fizzy. Give your answer as a fraction. Okay, well, the number of combinations then that have cheese in it and are fizzy, well, how many different choices has she got for those? So here, the number of choices is going to be, well, she's got 2 types of sandwich to pick from. She's got 3 types of drink, which are fizzy, but she's also got some snacks, which there aren't any restrictions on, but she can have any 3 of those snacks. She's going to have to multiply that by another 3. So 2 times 3 times 3 is 18. So she's got 18 different choices for her meal deal, if it's going to be cheese and fizzy. So then the probability that she would have picked that then is going to be successful outcomes, number of choices that end up with cheese and fizzy, divided by the total outcomes, which we worked out a second ago was 105. So probability then is going to be 18 over 105. Okay, that's it. Done. Question 16. Water is poured into a tank. The graph shows the number of litres of water in the tank. Okay, so we've got a graph here, and on the bottom axis it's got time in minutes, which you see is going up in 2s, and we've got a number of litres going up. The graph we've got is a straight line, which means that water must be going into the tank at a constant rate. And we're asked how much water is poured into the tank each minute. Circle your answer. Basically what they're asking us here is the gradient. So we can do that by working out what change in y is divided by change in x for any 2 given points on the graph. So the distance from there to there, in the y-axis is going to be 60, and the distance along there is 4. 60 then divided by 4 is 15. So every minute this is going up 15 litres. It's that one there. Can't draw a circle. There we go. Question 17. A and B are similar solids. Solid A is of length L and solid B is of length 2L. Alex says the volume of B is double the volume of A because the length of B is double the volume of A. Is he correct? No, he's made a classic error there. That is not correct. Similar in mathematics has a particular meaning. It means one is the exact enlargement of the other. So if two shapes are in the ratio of 1 to n in terms of their length. This is 1 to 2, isn't it? These things have got a ratio of 1 to 2 for their lengths. Then for areas of similar shape, that is going to be 1 to 2 squared. In other words, it's going to be 1 to 4. And then their volumes is going to be 1 to 2 cubed, which is 1 to 8. So her volume should be 8 times bigger than the length, or the volume should be 8 times bigger. So let's give a reason. The volume should be 2 cubed, or 8 times larger. Okay, question 18. Circle the two roots of 2x plus 3 times 5x minus 2 is equal to 0. Well, you get the roots when the equation is equal to 0, and those two things multiplied together gives you 0. Must mean one or other of them was 0 to start with. So either this first bracket here is equal to 0. So maybe 2x plus 3 is equal to 0, which means that 2x is minus 3, which means that x is minus 3 over 2. So that one there is a root. Or this bracket here is equal to 0. So 5x minus 2 is equal to 0. So 5x is 2x is equal to 2/5. So that one there is the other root. Question 90. The diagram shows a triangle and a trapezium, and we need to prove that A is equal to B. Okay. Let's have a look first at this selection or collection of angles here. Now here we've got angles at a point, and angles at a point sum to 360 degrees. So we know then that all those things together must be equal to 360. So A plus 65 plus C plus 115 degrees is going to be equal to 360. So A plus C plus 65 plus 115, that's 180, isn't it? So, and then taking that 180 over to the other side to simplify things a little bit, I'll get that A plus C is equal to 360. Take away 180, which is just 180 degrees. Okay, so that's my first equation. Now, what else do we know? We've got C and B, which are angles sitting inside a parallelogram, a trapezium. Now notice that these two sides are parallel, this one here and this one here. So C then and B are supplementary angles. They sum to 180 degrees. So we know also that B plus C is equal to 180 degrees. Okay, now comparing those two things, if A plus C is equal to 180 degrees and B plus C is equal to 180 degrees, that means that A must be the same thing as B. Question 20. In 1 month, the number of hours of exercise taken by 10 people are 4, 7, 2, 8, 6, 5, 1, 82, 3, and 9. Which is the appropriate average to use in this situation? Is it the mean, the median, or the mode? Now, I think the most appropriate one for this group of data would be the median. Now, why do I think that? Firstly, I don't think the mean is appropriate because of this value here. You can notice much bigger than the others. Okay, we call that one an outlier, and if I add all those numbers up and divide by how many I've got, then that 82 will have disproportionate effect on the value of the answer I get. So I'm going to write down that 82 is an outlier, some crazy fitness freak in there, and will have a disproportionate effect on its value. Okay, so that's why I don't think the mean is appropriate. Now, I don't think the mode is appropriate because all the numbers are different. So, and if all the numbers are different, there is no mode. Oh, I forgot to say what that was. So just on the value of the mean, I should write down there. On the value of the mean, and here I can write all the numbers are different, so there is no mode. So it can't be very appropriate, can it? Okay. Question 21. A, B, and C are points on the axes as shown. We're told that the area of triangle ABC is 28 units. Work out the possible coordinates of A, B, and C. Okay. So the area of a triangle is going to be half base times height, isn't it? So area equals a half base times height. And in this case, that is equal to 28, which means that the base times the height then is going to be twice that. It's going to be 56. So we're looking for two values here and here that multiply together to give you 56. Now, I know that 56 is 8 sevens. 8 sevens are 56. So, if this was 8 and this was 7, then that triangle would have an area of 56. So what might that make the coordinates then? So I know what C is then. C would then be 7, 0, wouldn't it? So that's a possible coordinate for C. Now, if the distance between A and B was 8, it looks like the distance between A and O is bigger than the distance between O and B. So let's say that one there is 5 and that one there is 3. That would make the coordinates of A 0, 5, and the coordinates of B would be 0, -3. Okay, so they're my three possible coordinates. Now, there are all sorts of other possibilities as well, but it doesn't ask me for all of them. It just asks me for a possibility. So I'm going to go with those three. So 0, 5, 0, -3, and 7, 0. So 0, 5, 0, -3, and 7, 0. Okay, others are possible. Question 22. Here is some information about the miles per gallon of 60 cars. And we've been given the miles per gallon and the frequency in the group frequency table, and we've been asked to draw a cumulative frequency graph. Okay, now when we draw a cumulative frequency graph, we are plotting upper class boundary, which is these ones, against cumulative frequency. So let's just use this table here to work that out. So my upper class bound is going to be those values 50, 60, 70, and 80. And my cumulative frequency, well, my first cumulative frequency is the same as my frequency. My next one is going to be those two added together. 6 and 16 is going to give me 22. Now, my next cumulative frequency is going to be those three added together, but I already know the first two add to 22. So I just need to add the 28 to my 22 to get 50. And then finally, that one there, I add all four together, or my 10 to my 50, which gives me 60. Always a good idea to just check that is the same as the answer that they give you at the top, because it is an easy mistake to make during a test. Okay, so now I've got my cumulative frequencies and my upper class boundaries. I can start plotting the points. Now there's actually an additional point I can plot first. I'm going to plot 0 against the lowest value there on my cumulative frequency table, my frequency table. So I'm going to plot 0, 40 as my, or 40, 0 as my first point. So my first point is going to be here, 40, 0. My next point is going to be at 56. So 56. Each one of these little squares is going to be worth 2, 2, 4, 6, 8, 10, isn't it? So that's going to be 6 there. My next one is going to be plotted at 60 and 22. So 60 goes with 22. It's that point there. My next one is 70 at 50. 70 and 50. And then finally at 80 and 60. 80 and 60 goes there. Once you've drawn your points, you can join them up with a nice, smooth, continuous curve going through each of the points. Should give you that distinctive S-shaped cumulative frequency curve once you're done. Okay. Right, use your graph to work out the interquartile range. Okay, now the interquartile range is the range of the middle half of your data. So if I've got a cumulative frequency of 60, if I've got 60 values, then 1/4 of the way through that, 60 divided by 4, is going to be 15. So my lower quartile is going to be at 15. Let's just get a ruler out and draw on at 15. So drawing across from 15 until I hit my curve and then draw down. Should give me my lower my lower quartile. So it should be there. And then my upper quartile is going to be 3/4 through my data set. So times in 15 by 3 gives me 45. So again, I'm going to read across from 45 to find my upper class bound. Sorry, my upper quartile. Spin that round. Okay, so that's going to be my Q1 there, and that's going to be my Q3, the upper quartile and the lower quartile. So I make Q1 equal to, what's that, 57? It's between 56 and 57. I'm going to go for 57, I think. And then the Q3 value looks to be 68. So then my interquartile range is going to be Q3 subtract Q1, which was my 68, subtracting my, what was it, 57? 57. 57, 68 subtract 57 is 11. So the interquartile range then is going to be 11 miles per gallon. Question 23. The equation of a curve is y equals x plus 3 all squared plus 5. Now this is already in the completed square form. So the question asks us, what's the coordinates of the turning point? Well, the lowest point on this curve is when that bracket is going to be equal to 0. And that happens when x equals minus 3. And when x equals minus 3 plus 3 is 0, all squared is 0. And that gives us a height of 5 at that point. So minus 3, 5 is going to be the turning point. It's that one there. Here is a cyclic quadrilateral, and we're told, oh, they're loving these ratios today. X to y is 5 to 7. So work out the angle W. Right, so I've got, what have I got here? I've got two opposite angles in a cyclic quadrilateral that add up to 180 here. So those two add up to 180. So x plus y is equal to 180. So that can give me an equation in x and y. And then down here, I can say then that y equals, what? So if I take x, I divide it by 5 and times it by 7, I'm going to get y. So y is 7x over 5. Now I can turn that into an equation like that. It's very similar to one we had earlier. I'm not sure why this paper is testing the same skill twice, but here we go. So y equals 7x plus 7x over 5, and x plus y is equal to 180. So I can be able to solve these two simultaneously then. Again, I can solve them by substitution. So subbing in that value of y into x, so x plus y, x plus 7x over 5, then is equal to 180. So x plus 7x over 5, x is 5x over 5, so 5x over 5 plus 7x over 5 is 12x over 5. So 12x over 5 is equal to 180. So dividing 180 by 12 will give me 12 into 180 go 15 times, and then times in that by 5. So x equals 180 over 12, which is 15 times 5, which is 5 15s are 75, aren't they? So x is 75. Okay, so now we know that x is 75. That one up there then must be 75 plus 20. It must be 95. And we know that these two are opposite angles in a cyclic quadrilateral, so they must also add up to 180. So w plus 95 must be equal to 180 degrees, making w equal to 75, 85 degrees. Question 25. 15 machines work at the same rate. Together, the 15 machines can complete an order in 8 hours. 3 of the machines break down after working for 6 hours. The other machines carry on working until the order is complete. In total, how many hours does each of the other machines work? Now, just take care of anything that's in bold. And that normally means that students kind of skip over those bits and then end up getting the question wrong. So the examiner, when they put things in bold like that, are doing you a favour. They're just kind of drawing your attention to an important thing that is often overlooked in these questions. Now let's take the first part of this. It says 15 machines work at the same rate, and together those 15 machines can complete an order in 8 hours. So our 15 machines over a period of 8 hours produce 15 times 8, what's that? 30, 60, 120 units of work. So that's how much they normally produce in 8 hours, 120 units of work. I'm just taking 15 and timesing it by 8. Okay, so then 3 of the machines break down after working for 6 hours. So they would have worked, and the other machines carry on working until the order is complete. So for the first 6 hours, all 15 machines are working then, aren't they? So 15 times 6. So all 15 machines were working for 6 hours. That would have produced 15, 60, that's 90 units of work. So they're short then by 30 units, aren't they? Now, so my 15 machines then, 3 are broken down, so that leaves me 12 machines. 12 machines functioning. So 15 subtract 3 equals 12 machines. Still functioning, so the other machines carrying on working until the order is complete. So they need to produce another 30 hours of work between those 12 machines. So then dividing 30 by 12, so then the time is going to be 30 divided by 12. 12s into 30 go 2.5 times, 2.5 times. So they're going to work for an extra 2.5 hours. So in total, how many hours does each of the other machines work? Okay, so the other machines then, it means the ones that carried on working, the 12 machines that carried on working. So they worked for 6 hours and then 3 broke, and then those machines carried on working for another 2.5 hours. So in total, the machines worked for 6 plus 2.5, which is 8.5 hours of work. 8.5. Question 26a, 0.7 reoccurring is the same as 7/9, we're told, and we need to use this fact to show that 0.07 reoccurring is equal to 7/90. Okay, well, 0.07 reoccurring is the same thing as 0.7 reoccurring divided by 10, isn't it? Okay, so we know, so that is the same thing as 7/9 divided by 10, or times by 1/10, which is the same thing as 7/90. I think that's enough. Okay, so using part A or otherwise, convert 0.27 into a fraction. Give your answer in its simplest form. Okay, so convert 0.27 reoccur into a fraction. Okay, so 0.27 reoccurring, that is the same thing as 0.2 plus 0.07 reoccurring. Now 0.2 is a fraction, is 2/10, which is the same thing as 1/5, isn't it? Well, let's just write it down as 2/10. Plus 0.07 reoccurring, we've just said is 7/90. So adding those two fractions together, just need a common denominator down there. Let's times that by 9 and that by 9. So I'll rewrite 2/10 as 18/90. So 18/90 plus 7/90 gives me 25/90. Okay, is that in its simplest form? Nope, because 5 and 90 are both divisible by 5. So that's 5/5's into 90 go 18 times. Can that divide any more? Nope. 5 is prime, so it's not going to go down any more than that, is it? So 5/18 is the answer. Question 27. There are 11 pens in a box. 8 are black and 3 are red. 2 pens are taken out at random without replacement. Work out the probability that the 2 pens are of the same colour. Oh, now we've got 2 words in bold here, so we need to be double careful. Without replacement, and they have to be the same colour. Okay, now without replacement means it's dependent probability, so we just need to take care with our fractions here. I'm going to draw a probability tree, I think. So I'm drawing 2 pens, so I'm going to make this red and black for our 2 types of pen. So there are 11 pens in the box, 8 are black and 3 are red. So 3/11ths are going to be red and 8/11ths are going to be black on the first selection. Okay, now let's draw on the second selection, red and black, red and black. Now, if I went up the first part and I picked red the first time, I've got 1 less red pen, so I must have 2 left, and 1 less pen, so it's 2/10. If I put red on the first selection, I've still got 8 of my black pens to select from, but I've only got 10 to select from there. And then the other way, 8/11ths. If I pick black first, then I've still got 3 red pens to pick from out of 10. Oh, this way it's only going to be 7 out of 10, isn't it? Okay, so that's my diagram done. Now work out the probability that the 2 pens are the same colour. So that means either it's going to be that route, red, red, or it's going to be that route, black, black. So the probability then that they are the same colour is the probability of red, red plus the probability of black, black. Now red, red is my top route, so that's 3/11 times 2/10. 3/11ths times 2/10 plus my probability of black, black is going to be 8/11ths times 7/10. So 3 times 2 is 6, 11 times 10 is 111, 8 7s are 56 over 111, and 6 plus 56 is 62 over 110. Now I could cancel that down further, but I can't be bothered, and you don't get any extra marks for it, so I'm just going to write that down as my solution, 62 over 110. Question 28. A, B and C are points on the circle x squared plus y squared equals 36 as shown. A is on the y-axis, B is on the x-axis, M is the midpoint of AB, and COM is a straight line. Okay, what do we need to do? We need to show that the coordinates of A are 0, 6. So we've got to find that coordinate there. Oh, that's very easy. X squared plus y squared equals 36. Any equations of a straight line centered on the origin is going to be x squared plus y squared equals r squared, which means that r squared is 36, which means our radius then is going to be 6. So if our radius is 6, then the distance between the center and the edge is 6. So that means that coordinate up there has got to be 0, 6, isn't it? So that's very simple. I kind of did it on the diagram. Right, work out the coordinates of B. Coordinates of B. What? Well, that's very simple. That's going to just be the other way around as well, isn't it? So if that's also 6, then our coordinates of B are going to be 6, 0. Throwing us the marks at the moment. And then finally, 28C, show that the equation of the straight line passing through C, O, and M is equal to Y is equal to X. Well, we said that B was 6, 0. So if I want to find M, the midpoint of that line, then I can just average out their coordinates then, won't it then? So the x coordinates of A and B are 0 and 6. So adding those together and dividing by 2. And doing that with the y coordinates as well. The y coordinates are 6 and 0. Adding those together and divided by 2. Tells me that the midpoint then is going to be the coordinate 3, 3. So that's 3, 3. So my line COM goes through 3, 3. It also goes through the origin. So it goes through 0, 0 and 3, 3. Well, it's super simple then. So line passes through line passes through 0, 0 and 3, 3. So then the gradient M is going to be 3 subtract 0 over 3 subtract 0, which is 1. So equation is y is equal to x. I think that's enough. Then finally work out the coordinates of C given your answer in surd form. Okay, where's C? C is down there. Okay, so it lies on the circle and it lies on the straight line. So we can find it then by solving those two simultaneously. So we know that y equals x, and we also know that x squared plus y squared equals 36. So there are two equations, 1, 2. We're going to solve these simultaneously. So substitute equation 1 into equation 2. It's going to give me that x squared plus x squared is 36. In other words, 2x squared is 36, so x squared equals half of that is equal to 18. So then x is going to be the root of 18. Now, it's going to be the plus or minus the root of 18, isn't it? So one of the positive root 18 is going to be the one up here. The negative root 18 is going to be C, isn't it? So the x coordinate is going to be your minus root of 18 there. And then what is the coordinate of y? Well, y is equal to x, so it's going to be minus root 18 again, isn't it? So y is also equal to that. Okay. Just check in. It doesn't tell us to put it in its simplest form, so there's no point in cancelling that down. Root minus 18 is good enough. Question 29. Here is a sketch of y equals sine x from minus 360 up to positive 360. Yes, there is. Write down the coordinates of P. Okay, so P is, well, if you remember your values for sine, they start at 0, and by the time they reach their peak at 1, you're at 90 degrees, aren't you? So P is going to be 180, 0. So 180, 0. Write down the coordinates of Q. Q, okay. So that's the point up there. So working backwards, so this point here is going to be minus 90. This is going to be minus 180. So Q is going to be at minus 270. So, and the height is going to be 1, isn't it? Because it's the top of the sine curve. So minus 271. Question 38. Work out the value of 81 to the power of minus 1/4. Now, with indices here, we've got two separate operations. We've got that minus sign in there and then the quarter. Now, the minus sign means 1 over. So 81 to the power of minus 1/4 is the same thing as 1 over 81 to the power of 1/4. So we can do, I've done the negative part. Now, what fractional powers are roots. So that's going to be the 4th root of 81. So what times itself 4 times is equal to 81? That's going to be 3. So 1 over 3. 1/3. 30b says write 16 times 8 to the power of 2x as a power of 2 in terms of x. So you need to write all this as a power of 2. So 16 times 8 to the power of 2x. So 16 is 2 to the power of 4. 8 is 2 times 2 times 2, which is 2 to the power of 3. And then I'm going to load that, I'm going to raise that to the power of 2x. So then that is the same thing as 2 to the power of 4 times 2 to the power of 3 raised to the power of 2x. And multiplying those two numbers together gives me 2 to the power of 6x. And then multiplying two numbers with the same base means I need to add the indices together. It's 2 to the power of 4 plus 6x. So my answer is 2 to the power of 4 plus 6x. So that is a power of 2 in terms of x. All done. So that's all. We've reached the end of the paper. How did you do? Let me know in the comments below, along with any questions you still might have. Don't forget to like and subscribe if you found this walkthrough helpful. If you didn't do so well, try revising around the topics you're struggling with before attempting another past paper. Good luck with your preparations and in your exams, and see you again next time.